viewers, welcome to Simplified Maths class. Today we'll be going straight to matrix 3, determinant of a square matrix. And understand that the determinant of a matrix is the scalar value of that matrix itself. Alright, please take note of that. The determinant of a matrix is the scalar value of the square matrix. And anytime we want to find the determinant of a matrix, the matrix itself must be a square matrix. That is, a matrix that has equal rows and columns. A 2 by 2 matrix is a square matrix. A 3 by 3 matrix is a square matrix. And a 4 by 4 matrix is a square matrix. So let's go straight to the determinant of the matrix. We'll take 2 by 2. Now, assuming we've been given a matrix A to contain the elements, say 6, 2, 5, and 3. And we've been asked to find the determinant. Therefore, the determinant of A will be equals to, we'll multiply the elements in the principal diagonal. This is the principal diagonal. So we'll multiply 6 by 3. Then we introduce a minus sign. Then we'll now multiply the elements of the other diagonal, which is 5 and 2. 5 and 2. So 6 times 3 will give us 18 minus 5 times 2. That's 10. So 18 minus 10 will give us 8. So 6 times 3, that's 18. And then you introduce your minus sign. 5 times 2, that's 10. 18 minus 10 will give us 8. That's the determinant of that matrix. Let's take another matrix, say B, maybe that has the values such as 4, 7 minus 2, 3. 4, 7 minus 2 and 3. Now, assuming we are asked to find the determinant of B, our determinant of B will be equals to, so we multiply the elements of the principal diagonal, which is 4 times 3. We introduce a minus sign after multiplying the elements of the principal diagonal. Then we'll multiply the elements in this other diagonal, minus 2 times 7. Alright, so we have 4 times 3, which is 12. Then you introduce your minus sign. The minus 2 times 7 is what you have here, minus 2 times 7. Minus 2 times 7. So we are going to have the determinant of B, this is another symbol for determinant of B, will be equals to 4 times 3, which is 12, minus 2 times 7 will give us a negative 14. So our determinant of B will be equals to 12. Minus will be plus 14. And that gives us the determinant of B to be equals to 12 plus 14, which is 26. So that's how we find the determinant of a 2 by 2 matrix. So we are going to go straight to 3 by 3 matrix. 3 by 3. Now, assuming we are given a 3 by 3 matrix, say A. A 3 by 3 matrix, let's say with the values, let's say 2, 3, 5. Or maybe 1, 2, 4. And then maybe 3, 0, 2. That's a 3 by 3 matrix. It has 3 rows and 3 columns. And we are asked to find the determinant of A. Therefore, the determinant of A will be, the first thing you have to do is to pick out these 2. And then pick out the 2 by 2 matrix. If we select out these 2 and we cross the row and the column where 2 is found, we cross it out, we'll have 2, 4, 0, 2. 2, 4, 0, 2. That will be the elements that will be left. Then we'll pick the middle number, which is 3. But the minor of 3 is always negative. So anytime we get to the middle, we'll always introduce the negative sign. Alright, so we have minus 3. Now we are going to cross the row and the column where the 3 is found. We'll cross it out. So we'll have 1, 4, 3, 2 left. 1, 4, 3, 2 left. Now we'll go to the last element, which is a positive 5. So it's always plus, minus, plus. Alright, so when we cross out the row and the column where 5 is found, we'll have 1, 2, 3, 0. 1, 2, 3, 0. 1, 2, 3, 0. So now it's easy to find the determinant of A. Now that you've done that, so you have 2, you open your bracket. The same way we'll be handling 2 by 2 matrix. 2 times 2, 4, minus 0 times 4, which is 0. We bring out our negative 3. 2 times 1, 2 minus 3 times 4, 12. We bring out our 5, and then 1 times 0, 0 minus 3 times 2, which is 6. So it's easy because you've done the 2 by 2 before now. So it's easy. So the determinant of A will be 2 into 4 minus 0 is 4. Then we'll bring our minus 3. 2 minus 12 will give us a negative 10. And then we'll bring our plus 5 into 0 minus 6 is minus 6. Take note of that. And so we are going to have the determinant of A to be equal to 2 times 4 is 8. And then minus 3 times minus 10 will give us a positive 30. And then 5 times minus 6 will give us a negative 5 times 6, 30. So our determinant of A will be equals to 8 plus 30, 38 minus 30. That gives us 8. So the determinant of that matrix will give us 8. Now, without waste of time, we're going to try another example of the determinant of a 3 by 3 matrix. So let's go straight to that. Now let's assume that we've been given a matrix, say M, and that matrix has maybe elements like 1, minus 2, 3, 1, minus 2, 3, and then maybe like 2, 4, 0, 2, 4, 0, and then maybe like 3, 2, 1, 3, 2, 1. And we've been asked to find the determinant of M. Now, watch me please. I can decide to still put another minus sign here so that I'll make it more complicated, but let's see how we can handle that. Our determinant, therefore, the determinant of M will be, we take the first element out, which is 1. Alright, 1 is positive. So when we cross the row and the column where 1 is found, we have 4, 0, 2, 1 left. 4, 0, 2, 1. Then we pick the center. Remember that the minor of whatever I say is always negative. So that negative will affect this negative to make it become a positive 2. Take note. Usually if it was a positive number here, would have introduced negative. But since it's already negative, we'll change it to a positive. Negative, negative will make it positive 2. And that's why we have 2. So we'll open our bracket and then we'll cross the row and the column where the 2 is found. We'll cross it. So we'll have 2, 0, minus 3, 1. 2, 0, minus 3, 1 left. So we go straight to 3. We'll cross the row and the column. First we take the positive 3. Of course, it's always plus, minus, plus. Alright, so we cross the row and the column. The row and the column where 3 is found. So you have 2, 4, minus 3, 2. 2, 4, minus 3, 2 left. Now we can go straight to the determinant, all right, because what you now have now is 2 by 2, 2 by 2. So you have 1 into 4 times 1 is 4, minus 2 times 0 is 0. We'll bring down plus 2. We'll open our bracket. 2 times 1 is 2, minus this times this. This times this. Of course, we'll convert this sign to become positive. 3 times 0 is 0. And then plus 3 into 2 times 2, that's 4. We introduce a minus sign. Then minus 3 times 4 will give us minus 12. That minus 12 will affect this minus to become plus 12. Please take note of that. Now the determinant of M will now be equals to 1 into 4 minus 0 is 4, plus 2 into 2 plus 0 is 2, and then plus 3 into 4 plus 12, that gives us 16. So we are going to have the determinant of N to be equals to 1 times 4, which is 4, plus 2 times 2, which is 4, plus 3 times 16, that gives us 48. 48. Alright, so 48 plus 4, that's 52. 52 plus 4, that's 56. It therefore means that the determinant of n will give us 56. Please, let's take note of the determinants of this 2 by 2 and 3 by 3 matrix, because it is with this we are going to go straight to matrix part 4, which is Cramer's rule. Cramer's rule is a rule that is usually used in solving simultaneous equation of both 2 unknowns and simultaneous equation of 3 unknown. And if you don't have the idea of determinant, you won't be able to do that, because Cramer's rule is anchored on determinant. So we are going to stop here for now until when we meet for matrix part 4, where we'll be solving problems involving Cramer's rule. But I please want you to subscribe to this video and also like the video, so that when once determinant or when once our matrix part 4 comes up, you'll be notified. It will pop up in your screen, and then you'll be doing me well as well. So thank you very much for attending the class. God bless you, and see you in the 4th edition of matrix, which is Cramer's rule. Cheers.